This is for the straight line. A is VAT, D is V initial t plus half AT squared, and V final squared is V initial squared plus 2A delta D. Now for the following object. For the following object now, V, it will be now not AT, it has to be GT. And the D, this formula here, since the V initial is 0, so I will say it is half GT squared. And for the V final squared, I will say it is 2G delta D. If I now use the last one here, and instead of V initial, I put 0, so I have 2A or 2G delta D. So these are the formulas if I'm talking about falling object. Now, what about rising object? In the falling object, V initial is 0. Imagine that you have a ball and you throw it down. So the first velocity is 0. Now look at the rising object. For the rising object, the V initial, it's not 0. So the V, if I want to find V, I will say it is G times T. Here I mean V at an instant point. Now D, it has to be, sometimes or some books, they not write D as a distance, they write it as X and Y. X, since I'm moving in a straight line, I'm moving in X axis. So instead of it, they write D as X. And here they write it as Y. If you write it D or Y, both of them are correct. So here now D, it has to be V initial T plus half G T squared. And the last one, V final squared, is V initial squared plus 2G delta D. And for this rising object here also, be careful. Since we are moving in the first, we said yesterday it's moving like this. So here the acceleration, it will be negative, and here it will be positive. So if I'm asking you to find the distance in this first half, you have to put G as a minus. If it's going down, it will be plus. In the falling object, since it comes with the direction of the gravity, so I keep it positive G. But if I'm moving in the rising object, at the first, as you know, it comes like projectile motion. In the first movement, in this way here, when I'm rising or I'm throwing the ball, the acceleration will be negative 10. And when it's reached the highest point and change its movement from upward to downward, the acceleration will be positive. So if
why the acceleration be positive, like it's going down?
Yes, ma, it's going with the direction of velocity, the direction of the gravity.
Okay, so it will be positive.
Yeah, يعني I mean, like you here and you are another one on the moon, which have the gravitational force is greater, who are in the earth or who are on the moon? On the earth, because you are sitting closer to the earth. So the highest magnitude of the gravity is near the earth. If you're going upward, the gravity will be less. So for each second of free fall, an object falls a greater distance it did in the previous second. Now, how far does an object in a free fall travel in the first second? Here now, you have a free fall. This ball has a free fall now. At the first second, here, he asked me now about the distance from, what is the distance that this this rock travel in the first second. How can we find this d? As we said, if I want to find d by the big four equations, we say d is v initial t plus half a t squared. So the initial speed is 0. The average speed is 5. Okay, why it's 5? Because as we said yesterday, at the beginning here it is 0. At the last here it is 10. Because it's v, I found it using v equal gt. So the v after 1 second is 10. The v at the beginning is 0. So because of that, the average speed, it will be 5. Okay?
Yes, teacher.
How from bring this 5? Look here. If we say d equal half, what is a? It is 10 times 1 squared. So the distance here is 5 if you use this formula. This is a way to find the distance if I'm asking you how long does the rock travel after 1 second. After 2 seconds, you multiply by 2 to the power 2, and so on.
Just on the falling object, right?
Eh?
Just for the falling object.
Yes, yes, just for the falling object.
So in each question, you say if it's falling or if it's straight line or like that.
At the quiz, if you have any question, you have now to check if the car is moving a straight line or if the rock is falling down. Because you will change.
We use kinematic, right? If it's in the straight line, we use the kinematic equation.
The kinematic, but with with a value of a. Here, if you see a falling object, you have to use these two formulas, v equal gt or v equal half gt squared. If the object is rising down, I throw it and it's go down, I will use the same big four equations, but instead of a, you have to put g. Now, pretend that a falling rock is somehow. Now, how did they know the how? What's the speed, the velocity or the speed in each point? They put the equipment or device. We call it an odometer. This odometer, it's reading the distance increasing with time. They read that this ball is going 2 meters in 2 seconds. So the velocity here, it will be 1 meter per second squared. So this type of equipment is equipped with a rock. It tells me about the distance that the rock travel and the time. So now at the 10 of and the end, of 1 second, the rock has fallen 5 meters. As we said here, d is half gt squared. So if t is 1, as we said before, it will have to be 5. If t is 2, 2 squared times 10 half. 10 times half times 10 is 5 times 4, it's 20 meters. And after 3 seconds, it has to be 5 times 9, which is 45 meters. This is a way how can we find d at any point of or at any certain time I ask you about it. So these distances form a mathematical pattern. At the end of time t, the object starting from rest. So this one, it's used only if the object starting from rest falls a distance. So this is only for the falling object when the object starting from rest. I will say D is equal half GT squared. This is here a table. As an example, at point 3, as we solved, it's 45. At point 5, you will say now it is half GT squared. But since 5t is 5, so you will say half times 10, 5 squared. 5 squared is 25 times 10, 250. Divide by 2, it is...
G is always 10.
The G?
Yeah.
Yes. For the falling and for the rising, it's always 10.
But not like the acceleration, because the acceleration don't have...
Okay, the straight line motion, the acceleration will change.
Yeah.
The
Like delta V over delta T.
The acceleration of helicopter and so on. Not helicopter, sorry. يعني something going fast.
Okay.
So by now, you used a freely falling object to describe the relationship between the distance traveled, acceleration, by using this one. Well, the same principles apply to any accelerating object whenever an object's initial speed is 0 and the acceleration is a and the distance. Every time, if I'm talking about a car and this car is starting from the rest, so you will say the velocity is a times t and the distance is half at squared. But if I have a freely falling object, this a, it will be g, and this a also, it will be g. So the velocity, it will be now gt, and the distance, it will be half gt squared. Now, did you see now the white slides? Physics.
Yes.
Okay.
Yeah.
So now, what is the free fall? The free fall is the movement of an object in response to the gravitational attraction. This is the mean of free fall. When an object is released, it falls toward Earth due to the gravitational attraction Earth provides. As we said, if there's an object, it falls, it's gonna be affected by the gravitational attraction. As the object falls, it will accelerate at a constant rate of 9.8 meter per second square, regardless of its mass, as we say when the rock and the feather, when they are throwing at the same time. However, to make calculations more experienced and easier to do without calculator, this number will be written as 10 throughout this book.
Actually, we said it last period about...
Yeah, just but I want to summarize it and start talking about these equations and solve some problems here. So this is for the freely fall object, the meaning of it. Now, this displacement of a falling object in a given amount of time is written as delta D is equal V naught or V initial delta T plus half G delta T squared. If I'm asking you to find the final velocity of the falling object, you will say it is V final squared equal V initial squared plus 2G delta D. And as we know, the last one, it was V final equal V initial plus A times delta T, but instead of A, you have to put as G delta T. This is for the...
Teacher?
Yes, Rose.
Teacher, delta T squared, how to be in the question? Like we write T squared initial minus T squared final?
Yes. Okay. Now let's have these questions here. King Kong carries Ray up at the 321-meter tall Empire State Building. So there's a building. Its tall is 321 meters. There's a building here. And this building, it has an distance 321. At the top of the skyscraper, Ray's shoe falls from her foot. How fast? So here, she's sitting here, and this her foot. What? This is her foot. It falls down. So this word means that I'm talking about falling object. How fast? What's the meaning by how fast? I'm asking you about what?
The velocity.
The velocity. Thank you. So how fast will the shoe be moving when it hits the ground? So it moves under it hit the ground. How fast will the shoe moving? So the first thing here, since it is falling object, so what's the V initial will be?
0.
Will be 0. Then what about G?
It's going to be 10.
10.
Or 10.8.
What is delta D, or the distance?
321.
321. This is all the information I have. And what I need to find?
The final.
Now, so which formulas shall I use? That's helped me to find V final.
V final squared equals V
Yeah.
initial squared plus 2G multiplied D.
Thank you. So V final squared is V initial squared plus 2G delta D. Now, V initial, as we say, it is 0 times 2 times G, which is 10, delta D, which is 321. These are equal to V final squared. Then 2 times 10 times 321, 20 times 321 is 6,420. This will be a V final squared. Now, if I want to find V final, I will put them under square root. So the V final, it will be the square root of this number, which is 80.1 meter per second square.
And of course, we not make it negative.
Ah, yes, yeah. Is it clear now?
Yes, teacher.
Yeah.
Let's go now to the second one.
Teacher, only if the question says it will declare, we will say it's negative, right? But just
Yes.
in this case.
Yes. Now, there's a baby blue jay sits in a tall tree awaiting the arrival of its dinner. As the mother lands on the nest, she drops a worm towards the hungry chick's mouth. But the worm misses and falls from the nest to the... Now all of them are English. Now let's go to physics. But the worm misses and falls from the nest to the ground is 1.5 seconds. How high up is the nest? How high? I'm asking you about what?
Distance.
Find the distance. Yes. So now I need to find, I need to find the distance. Now, let's repeat the question. There's a checks or worm. It goes down, it falls. So that's mean I'm talking about falling object. Since it's falling down, so I'm talking about the falling object. So what is the V initial now?
It's also 0.
It's 0.
So 0.
Like the falling object is always 0.
So the V here is 0. Now what about G?
It's equal to
10.
10. And what is the given information here?
The time, which is 1.5 seconds.
The time here, which is 1.5. I need now to find delta T. So which formulas shall I use?
Half AT squared, half GT squared.
Yes, thank you. So D now, I have to use half GT squared.
Teacher, in G, is it 10 meters per s squared?
Yeah. So half. Where is G? It is 10. T squared, which is 1.5 squared. And after you multiply 5 times 1, you will get 11.3 meter. So this is the distance, or the highest, the distance from the nest to the earth or to the ground. 11.3 meter. Let's go now to the last one here. Now here, there's a giraffe who stands 6 meters tall, bites a branch of a tree to chew in the leaves, and he lets the branch fall to the ground. Before I continue now, what's the given information I have here?
Distance.
We have D.
Just
The
6.
distance is 6.
Then he lets the branch fall to the ground. So I'm talking about falling
The
object.
falling object, so
So
G equals 10.
0 and the G is 10. How long does it take? What's the meaning by how long? I'm asking you about velocity
Velocity.
or distance or time?
Time.
Yeah, thank you.
Time.
So you will find now the time. We have to use also D is half GT squared. D now is what? Is 6.
6
Half
times
10
10.
T squared. Then 5T squared is equal to 6. So 6 over 5 which is 1.2 equal T squared. So the time is the square root of 1.2, which is 1.1.
Teacher, is it 1.1?
Yeah?
1.2 squared equal 1.1.
Oh, yes, 1.1. Sometimes now you can make a new formula for finding T that you can say D, since is D is half GT squared, by multiplying 2 by both terms, you will get 2D equal GT squared. Divide by G, divide by G, so T squared, or T, it will be the square root of 2D over G.
And teacher, this is not in our book, right?
Sorry?
This is in our book or no?
I think yes, it's written.
Okay.
So now this is another way to find g. Then quickly you will say square root of 2 times 10, 2 times 6 over 10, 12 over 10, the square root of it, and you will get the answer. This is a fastest way to find the answer. Which you will have only also 1.1 second. Is it clear?
I think the last one is easier.
Yes, but here just you have to know if it is full or it's going in the straight moving object.
Yes, yes.
Okay. Now I stopped as I finished. I think let's go back to the please. Okay. Now, an apple drops from a tree and hits the ground in 1 second. Okay, so the time here is 1.
It's 1 second.
What is its speed upon striking the ground? What its average speed during the 1 second? And how high above ground was the apple when it's first dropped? So here there's an apple. It drops from a tree. So here the V initial is 0 and hits the ground in 1 second. So the time here is 1 second. The first
And G equals 10.
yeah, أيوة, and G equal 10. Now what is its speed upon striking the ground? So I need to find the speed or the velocity.
Velocity.
What you have to use? You have to say it is G times T, which is 10. So after 1 second, the velocity here is 10 meters per second. Now, what is its average speed during the 1 second? The average speed, what does it mean?
Final distance over final time.
بالضبط. Thank you. Yes. So here is 10. I found it as 10. Here it's the initial 0 and during 1 second. So to find the V average, we will say it is V initial plus V final over 2. V initial plus V final, it is 10. 0 plus 10 is 10 over 2. So the answer is 5 meters per second. The last one. How high above ground was the apple when it's first dropped? How high? He asked me about
The distance.
distance. Just half GT squared. Half times 10 times 1 squared, which is also 5 meters. So the V final is 10, the V average is 5, and the distance is 5 meters. The speed when it strikes the ground is 10, the average speed was 5, and the apple dropped from a height of 5 meters. That's it. Do you have any question?
No, teacher, thank you.
No, thank you.
Thank you so much for
you.
listening.
Have a nice day.
Have a nice day.
Thank you so much. Have a nice weekend.